Hi, welcome to another episode of Practical Programming. Our today's problem would be related to factorial, so let's have a look at our details. It's just that we would be given with a number and we need to find its factorial. So input to our program is going to look like this. We could have 5, 10, 8 and is followed by its output. For 5 it's going to be 120 and for 10 and 8 quite a big numbers we would be dealing with. So let's try to understand our problem. Before we jump there, there's something can be very true about factorial. It takes a minute to learn them and lifetime to master. And why is that? Is because of this. If you take a number, any given number 5, and the exclamation mark denotes in a mathematical term that we are trying to find is factorial, so it's going to look like something like this. So we take 5, reduce it by 1, and we keep multiplying until we reach 1. So 5, 4, 3, 2, 1, and we multiply that and we get 120. As you can see, for 5 you get 120, and as you can increase the number 8 and 10, its factorial will increase as well, and they can get pretty big. That is why when your given number is small, it's easy to get the factorial, but as it grows in number of given, so is the output is. That's why sometimes your algorithm or your program which you're writing to get the factorial needs to be efficient enough to get the output as soon as possible. So let's jump to the code. Alright, we are finally here. So let's try to declare a class name, test, where I am post 107 factorial. Right, that looks okay. Public static void main, and let's run this thing, hoping my code is still working, which is nothing actually. Alright, let's try to get user input first. Private static final scanner, right, and let's initialize that. Scanner system dot in, not out, it's in. I'm not able to write anymore. Alright, let's take a user input and given number, given number is equal to scanner next int. So we would be taking int from the user, and let's try to print that. Given number is given number. Let's run that. Is equal to, fine, we are able to get that. That is all right. So let's just get rid of this one, okay? And we're gonna write a method which will give us factorial. Get factorial of this given number. It's gonna give me an error because the method is not there, so I can do alt enter on that name. It will allow me to create this. So I know it's gonna be an integer or some other big value, not a boolean. Boolean is only yes or no, which is true or false. I'm gonna say int, and here I need to give a result, okay? So to make it interesting, we're gonna use recursion. Some people call it very fancy. I don't like to use it. It's hard to understand and hard to make, and many things can go wrong if you are not vigilant while writing it. Okay, return 1 if given number is equal to 1. Okay, if you do not get this in the first go, don't worry about it. It's recursive functions are supposed to be nonsense, because they have a concept called dynamic programming there that everybody expects you to use instead of recursion, because not every place would be useful. Let's say if the given number increases, okay, and the way the function is written, if you look at this, it's going to keep calling itself over and over. So if there are too many callbacks to that individual method, what will happen is you'll get a stack overflow error. First, let's just check if this works, okay? Well, let's run this code, and I'll do 5. I get 120. Let's run that again. 8, still acceptable answer. And let's do it for 10. I guess I'm still able to get all the answers I need. So our factorial using recursion works. The only problem is that if the given number is too big, and if this keeps calling itself, we're gonna get error. What I mean is, let's just run that and I'll show you. Let's say our given number is too big. So that's exactly what I mean. You see how many times the same method was called and it throws Stack Overflow error. So that is something we do not want to deal with. So we're gonna write in another manner. Let me just rename that to Shift F6 to get factorial of method, oops, method 1. Alright, I'm gonna get another name here. Oops, Control Y, that should delete it. And here I'm gonna say 2. So that method is not there. I'm gonna do Alt Enter. Let me create that. Again, it says boolean. It's not boolean, it's gonna be integer. You know what, let me write double because they are usually big. It factorial can be big in numbers, so I'm gonna choose double, but to keep my sanity here, let me do int for simplicity. So I'm gonna be returning a result. Okay, so let's say int result, oops, result is equal to 1 for now, and let me loop through the given number. Okay, and I'm gonna be returning result. Oops, my bad. What's going on? Alright, so let's use for loop, and this is gonna be our index, and it's going to start at 1. It can start at 2 because no matter what you do, multiply it by 1, you're gonna get the same number. So this is gonna be a given number, and we have to multiply that given number itself, so we're gonna do equal to. So it's gonna start from 1 to all the way to that given number. So let's multiply this. Result is equal to result multiplied by that index. So as it loops through 1 to that given number, the index will keep on changing and it'll keep multiplying itself with the result, and will return the result, which we will print over here. So let's run that. So if I say 5, I get the answer. Okay, let's do 8, still right. And if I do 10, the answer is still acceptable. So we are able to write, so this is something they call linear dynamic function, or programming, I would say, or a linear way of writing instead of doing the recursion. So before I leave you with the absurd solution which I just did, let's recap what we have done so far with the factorial. Let me just assume given number to be 5. Okay, that's our given number. So how do we get factorial of this? 5 factorial is actually 5 multiplied by 4 multiplied by 3 multiplied by 2. That is not multiplication sign, this is, and then multiply that by 1. I'm not sure why I'm doing that, because multiplied by 1 you could get 1 unless there's 0. So we get 120. So that's our factorial. That's how we get it. So I took some easy ways to show you how we actually achieve the factorial, but multiplication is a very expensive operation. So if your given number increases, it's going to take way more time to calculate the factorial. So what do you do is, there are other algorithms available, and some people completed their thesis on this algorithm to achieve a better way of finding factorial. You should go look at them. Thank you so much for your time, and please subscribe that I can make more videos.